So untrue. What?
All right, guys, we are looking in more in depth at amplitude and period today. We are focusing on sine and cosine equations. So the general form of the equations is A sine bx. And sometimes they'll put parentheses on the bx, sometimes they'll leave it off. So I'll put the parentheses on that one. Or you can also have cosine. So basically on that, the parentheses are optional. They're only not optional if they have a translation left and right. If they have that plus or minus in there, then you have to have the parentheses. If there's just a number in front of the x, then they will not. Okay, amplitude. You guys have already looked at a little bit. You get that from the number in front of A. The amplitude, when we talk about amplitude, is always a positive number. So we're going to write the absolute value of A because it is always positive. So if they stick a negative in front of it that flips it over, it does not change what the amplitude is. The amplitude is still a distance from your midline to the max and min, and so that's always going to be positive. Now we're going to look today at changing the period of our functions, which we have not done before. So there's a formula for that as well. B is the number in front of x. The bigger you make that number, sort of the shorter your wavelengths are. And so this is the relationship. Remember that 2 pi is the standard for just sine and cosine. You guys have seen that. If you divide that by the absolute value of b, which just means if it's negative, take that off, that will give you the period. Okay, so the period equals 2 pi over b. Also, I'm going to put over here, since we have a little bit of space, if you need to find b, you can take 2 pi and divide by the period. So that's another thing that you can get from this. So 2 pi is the normal period that you have from the parent graphs. If I stick a number in there, it's either going to make the wavelength longer or shorter, and we will look at that here in a minute. Okay, so let's go down and look at our examples. So it says find the amplitude and period for each given trig function. Note any reflections or translations from the parent graphs, y equals sine x and y equals cosine x. When it says note, what I'm meaning is you're going to write them down. So you're going to write down everything that happens to this graph, comparing it to the original graphs. Parker, Mark. Okay, find the amplitude. So we're going to start with the amplitude. So if I have a 3 out here, without graphing it, what's the amplitude going to be? 3. So I'm just going to put amp for abbreviation equals 3. The absolute value of 3 is 3. I don't have to do anything else with it. You better be writing this down. Okay, then when I go to do the period, the abbreviation for period, which I've told you before, but I'll write it up here, is like a capital T for time, so I'm going to use that just to make this shorter. I have to take 2 pi divided by the number that's in front of x. That's what's changing my wavelength. So if I put that there, I have 2 pi over 4, and then you reduce the fraction. So 2 over 4 reduces to 1/2. You'll just get pi over 2. And then is there any other, there's no negatives, there's no reflections. I don't have any up, down, left, or right stuff. So for that one, I can just call that good. Amplitude and period. Okay?
Good job, everybody.
Let's look at number 2. So on number 2, let's start with amplitude and period, and then we'll look at other things. So I have -4 there, but the amplitude is the absolute value of -4. We just want the distance from the midline. So my actual answer is 4. You do not put a negative on amplitude ever. Okay? Then for the period, we would do 2 pi divided by the number in front of x, the coefficient of x, which is 5. And then that cannot be reduced. 2 and 5 don't reduce, so I can just leave it. Is there anything else that's been done? What does that negative do? Okay, so the negative is a reflection over x. I'm just going to put reflect over x-axis. And so that's something. And what about the +2 that's on the end? That moves it up 2. You could write translation up 2. I will take up 2. So anything that is changed from the parent graph cosine we are going to write down. Okay?
Maybe.
Okay, let's take a look at number 3. So let's do the amplitude first. So the amplitude should be easy on this. What is it? 2. Okay, absolute value of 2 is 2. Now the period for this one's going to take a little bit of fraction work, so I'm going to not talk quite so fast and take you through the fractions. So for the period, I have 2 pi divided by 2/3. When you divide fractions, we do this, some of you learned from Dr. Nichols, copy dot flip, invert and multiply is another way. We're going to break this apart. So I'm going to think of this as 2 pi over 1. So I'm going to make that first number into a fraction. I'm going to change it to multiply, and then I'm going to flip the second fraction and make it 3 over 2. Because this basically is like a division sign. You're going to change it to times, flip, and then the 2's are going to cancel. So I'm just going to get 3 pi. Okay? So is there anything else that I should write down that is a transformation?
Down 1.
Down 1 for the -1. Good. You guys got that part down at least. So what this does on this one, if they put the 2/3 in there, that's changing the period to be 3 pi instead of 2 pi. It stretches it out a little bit. Back over here, when they had pi over 2 and 2 pi over 5, when they put whole numbers in there, that squishes it together. Okay, so it's just changing the period for those waves. Let's look at number 4. So when I do my amplitude, remember it's always positive. So ignore the negative sign. The amplitude would just be 3/4. Okay? The period is going to be pi divided by 1/2. So we're going to invert and multiply. So I'm going to change pi to pi over 1.
2 pi or just pi?
Oh, it is 2 pi. Thank you. I needed that.
Else caught that.
It is 2 pi. So 2 pi over 1. And then the 1/2 will change to 2 over 1. So there's nothing that's going to cancel. I'm just going to have 2 pi times 2, which makes it 4 pi. Okay, you're right. There is a reflection over the x-axis we need to write down. So reflection, I'm just going to put reflection x-axis. And then I think that's it. So if there's any translations, anything weird in there, you're going to go ahead and list everything that they added to the sine and cosine equation. Now, the next part of this is going to be to write an equation given a whole bunch of information. So they're going to tell us whether it's sine or cosine, because we need to know that. They're going to give us amplitude, period, possibly some other transformations. And we are going to write the equation. So this is a stepping stone to being able to look at a graph and write the equation, but we're going to start with the information just being given to us in text first. So first, they're telling us it's cosine. They're telling us the amplitude is 4 and the period is pi. So we can start off by doing y equals, and you can actually use function notation. If you want to do f of x, you can. I'm just using y because it's a little easier. And it doesn't say anything about flipping it over, so I'm just going to put 4 cosine. And I need to figure out what's going to go in front of x. So if my period is pi, what we wrote at the top is we can get b, which is this number right here, by taking 2 pi divided by the period. So 2 pi divided by the period would be 2 pi divided by this pi that they gave us. And so the pi's are going to cancel, and you get 2. You put that into the equation. So 4 cosine 2x. So really the only work you're going to have to do is a little bit of fraction work, potentially, to figure out the number that goes with x. Everything else should be a little bit more obvious. You can just stick it in. Okay? Let's go ahead and take a look at number 6. Okay, so number 6 says it is a sine equation. The amplitude's 3, period is 4 pi. So we know it's going to be y equals 3 sine of something x. And so we're going to take 2 pi divided by 4 pi. I know you guys have it, but I'm going to go ahead and work it out. Not everybody knows what you're doing. So it's always 2 pi divided by the period. The period's 4 pi. The pi's cancel. We have 2 over 4, which reduces to 1/2 x. Now, here's something that's tricky. On a lot of the worksheets, IXL, SATs, they're not going to write 1/2 x like this. They're actually going to change it and write it y equals 3 sine of x over 2. So basically, they're just taking that, making x over 1, and combining that into one little fraction. Okay? Same thing, but this is what you're typically going to see on an answer key. It's going to look like this. I will accept either one because they're the same thing, but I want you to realize going into things like SAT tests and whatever you guys have coming up, that they may have it written like this, and it's the same thing.
Maybe.
ACTs, SATs, whatever you guys are taking. Okay, let's go down to number 7. Okay, it's sine. The amplitude's 2, period's 3 pi, and it's reflected over the x-axis. What's that reflection going to do to the equation?
You make negative.
Okay, so I'm going to make it -2. So you're going to put the negative in front of that amplitude number. It's sine. And then it's going to be something x. So we will put 2 pi over the period, which is 3 pi. Pi's cancel. We get 2/3. So 2/3 x, or you can also write it as 2x over 3. They just take the x in the top because that's x over 1. This is what you're typically going to see in an answer key. I think they actually like this better just because it takes up less space. It sort of squishes it, but same thing. I will take it either way. Just make sure you've got everything in there. Okay? We ready for 8? I'm going to throw in some fraction ones so we can practice that. So we all love fractions. All right, so on number 8, it's cosine. The amplitude's 1/2. Period's pi over 2. It's translated down 2. So we've got a little extra something there. So I'm going to have y equals, do I need to put a negative in there? No, no reflections.
No.
So just 1/2 cosine something x. And then the translated down 2 units, what would I put on the end? Just a -2. So we just need to figure out the number with x that comes from the period. So we're going to take 2 pi divided by pi over 2, or you could go ahead and just do 2 pi over 1 and flip this number 2 over pi. The pi's cancel. 2 times 2 is 4, so it's going to be 4x in there, and that's my answer. This is, we call this b. That's the number that goes in there. You take 2 pi divided by the period, and then simplify the fraction, and that's the number that goes in. 2 more. We're almost done. Just little details, making sure we're getting all the fraction stuff, etc. down. Number 9, it is a sine function. The amplitude's 5. Period is 2 pi over 3. It is translated up 3 units. So it doesn't say anything about reflection, so I can go ahead and put y equals 5 sine, leave a blank with the x. It's translated up 3. So you're right, we're going to put the +3 out there. And then we just have to figure out what's going to go here. So that's b. So b is when we take 2 pi over, I'm just going to go ahead and flip it. 2 pi over 1 times 3 over 2 pi. Are you guys okay with me going ahead and flipping that?
Yeah.
So the 2 pi's cancel. I get 3 over 1, which is 3. Put the 3 in there. The only thing that's tricky about any of this is the fractions. Copy, dot, flip, or invert and multiply. However you learned it, whatever makes sense to you, that's what you have to do. One more. We are almost done. So on number 10, it's cosine. The amplitude is 1. The period is 3 pi over 4. It is reflected over the x-axis. Now, you can write -1 or just the negative. So I will write it both ways. -1 cosine blank x, and then there's no translation, so I don't have to worry about that. Or we can have y equals just negative cosine something x. They don't have to put the 1, because if you have the negative there, the 1 is implied. So we're going to take 2 pi over 1 times 4 over 3 pi. We're flipping that. The pi's cancel. We get 8 on top and 3 on the bottom, so that is 8/3. So you can put 8/3 x. On this one, I'll just simplify it and make it 8x over 3. So you have some choices there on how you write the answer. Those are both correct with the -1 or just the negative. 8/3 pi or 8/3 x or 8x over 3.